know nobody cares, but still going to do it. The Voyager mission, which the Voyager, both of those things are still flying to this day, and they've landed outside of our solar system at this point. It's a fascinating thing that we did in the 70s. But anyway, and a mathematician solved the how we could get those to visit all four of the planets of our outer ring, starting with Jupiter. So pretty cool. Anyway, so the process of making this a perfect square trinomial, you take half the middle term, then square it. And don't tell me you don't know how to square -7 halves, because -7 squared is 49. 2 squared is 4. That's how you square a fraction very easily. Oh, this is coming out of left field because I didn't watch the YouTube video yesterday. Laying it on thick here. All right. Now, it'll look a little clearer on the next one, but you expect me to factor this yellow trinomial? And actually, I do. Because what this factors out to become is x minus 7 halves times x minus 7 halves. You created this by the process of completing the square, by the process of taking half the middle term, then squaring it. You have made this a binomial times itself. I'll prove it. X times x, x squared. -7 halves and -7 halves, x, both of those with an x. When you add those, that becomes -14 halves. -14 halves is -7x, our middle term. And then -7 halves times -7 halves is 49 fourths. Check yourself before you wreck yourself. Factoring is the reverse of foiling. All right, you know what I'm right here? I'm getting ready for it. Lexi Samulus knows that 6 is 24 fourths. Why would I do that? Because I know the future and it looks bright. Now I can subtract 49 fourths from both sides, and I have a common denominator that I can compare. Oh, I don't know how much time we have to do this. I think it took some time trying to get the video started. And then this is -25 fourths. And then for my 7th hour, especially those naughty that didn't watch the YouTube video, at least it was like 10 more minutes. Like that's you can't give me 10 minutes. Come on. That's vertex form. The vertex is now 7 halves, comma -25 fourths. All right. Let's do a little better one that doesn't end up having fractions, but we do have a problem. So the first step for completing the square is you do group the first two terms. You cannot take half of -20 and then square it when there's a 2 in front of here. It just won't factor correctly. So in the next step, whatever you do to one side, do to the other. So put a blank there. You have to factor out a numerical GCF, and then 20 becomes 10 negative. And then put a blank here for the completing the square process. This one does not play. Just get it out of there. Do not divide a 2 from that one. Just get it away from being part of that. All right? So now, what's half the middle term and square it? Well, real fast, half of -10 is -5. -5 squared is 25. Whatever you do to one side, do to the other. And then mark yourself wrong. I hope I scared you by yelling at you. The reason that's not 25, does anyone know? Put up your 2 hands if you know what actually goes on the left side. What did you actually add to the right side? You did not add 25. You added, come on, you can do it with your hands. I'm doing it in the computer, but I don't think you can see me. Nice, Nadia. You're the only one I've seen do it. It's actually 50 that you added. See, this is all about balance. Whatever you do to one side, you do to the other. You actually added 50 to the right side. You added 2 times 25. So do happily put that in the notes to make sure that you understand when you have that multiplier out there, it does change what you did here. All right, so I won't be able to entertain any questions on this. You need to go into the YouTube video from yesterday and watch the last 10 minutes for 2 more examples of this. And then you write some words on it and stuff. And I'm going to write this final answer. I have created a perfect MA scenario by this process. 1 multiplies to 25 and adds to -10, -5 and -5. So it's x minus 5 squared. I'm going to subtract 50 from both sides. Subtract 50. Sometimes when I do too much, especially with those that are a little behind on the math skills, that's how this becomes a negative 49. That's why I can do this in 2 steps. So completing the square is a 2-step process to change a parabola into vertex form from standard to vertex. And then the vertex for this one, I'll write that one down, is 5, opposite, negative 49. Same, far away. Okay? All right. Now we're going to go into the notes for today. And you should already know this. This should already not be a big deal. A lot of end behavior, and then we are going to end with some factoring. Because it is part of the process. And you feel free to write what you want. You make this super fast, though. I know this looks like a lot, but you could write some minimal stuff here. Like, first things first. Whoa, what just happened? What is going on? Oh my gosh, don't do it again. Don't start just like some sort of ghost on my holy crap. Is anyone seeing what I'm seeing, or am I starting to flip out? Did everyone see that disappear? Thank you, Nadia. Everyone else, they're just looking at me like I'm a weirdo. You may be right, but huh? What? Why? I just got to stay here. I can't go any further in. It just like disappears. Okay, here's what we got. Just cursed. X squared is we already did this. I don't know why I'm doing it again. We did this when we did our family of functions, and we did our limits. Like, what's the end behavior as x goes to infinity? What does y go to? Infinity. All right, feel free to write what you want. I'm not going to give you time to write all this stuff. As x goes to negative infinity, what does y do? Well, that also goes to infinity. When I put a negative in front of the x squared, it flips it upside down and flips these end behaviors. So as x goes to infinity, y goes to negative infinity. Input, output. That's all we're assessing when we look at that stuff. Okay, what about cubics? This is also one of our family of functions. As x goes to infinity, y goes to infinity. As x goes to negative infinity, so does y. If we put a negative in front of x to the third, it flips it, and therefore flips the end behaviors. All right? Okay, you already had those. Those are already in your 12 functions from section 1, chapter 1, I mean. And there were others, actually 7 or 8 of them we really focused on, and these were definitely one of the 7 or 8. But here's the idea of this one. What happens when I have an x to the 4th, an x to the 5th, an x to the 6th, an x to the 7th, and so on and so on and so forth? The behaviors end up being the same. Oh, I got something funky going on here. I can see some distortion in my picture. Oh, this is great. This is probably going to end very well. But here's an x to the 4th. It looks very similar to the x squared. As a Fattermact, yes, the end behaviors are the same. Oh my gosh, there's a little stall in the writing. You don't see it, but I'm writing, and then it appears. Hoi. Okay, so an x to the 4th ends the same way as an x squared does, both positive and negative. And an x to the 5th ends the same way as an x to the 3rd. All right? And an x to the 6th is the same as an x to the 4th. An x to the 7th is the same as an x to the 5th. So we're talking about degrees and how they behave at the ends. Won't be able to fill that in. And you're not, oh boy, I don't know what's going on. Okay, we all see it. I let go. It disappears. That is a first time in for, oh boy. That was like a black hole right there or something. I don't know where we just went. Okay, what is happening? I'm freaking out, man. Does everyone see what I see? The blackness on the screen? I got to say, like right here. Okay. So you can't barely see this, but this says negative, and I kind of lost my negative, 3x squared plus 4x plus 5. The top dog lead degree is a -3 on an x squared. So I will not have a graphing calculator to prove this. I will have to know in my brain that's how that ends. I'm going to go to the next one. I think this was like supposed to be 2x cubed minus 2x squared minus x plus 1. The 2x cubed is the top dog that dictates how this is going to end. Don't look at this one over here. The graph actually is the one that you see there with a little bit more character in the middle, but look at the end behaviors. They end just like the positive x cubed parent function. So I'll go to the limits here shortly. 2x to the 4th. I'm terrified what's going to happen when I do it, though, electronically. 2x to the 4th is the top dog of this one. So it will end like an x to the 4th. All this other stuff gives that character in the middle. Still doesn't change how the ends happen. The 2x to the 4th ends like this. And then a positive x to the 5th with a whole bunch of other stuff. Oh, that's not part of it. Just gives me that character in the middle. The positive x to the 5th gives me these ends. So if I pick a couple like these last two, okay, how did I not know that was going to happen? Okay, we'll stay here. We'll stop moving this size thing. Infinity, infinity. This one is as x goes to infinity, it's infinity. As x goes to negative infinity, it's negative infinity. No idea what's going on here, why this is behaving like it is. Okay, everyone good so far? Right? You're not going to have a calculator to prove this, though. You are going to have to know this, right? And know what's going on without looking at that. So when we have a quiz, this is in the no calc part. Don't write the stuff off. Actually, don't write any of this. But I can't zoom in on it because you see our technology issue yet again. The curse of 7th hour, 2 days in a row. Not you guys, there's just something weird going on. All this says is when the degree is odd and you have a positive leading coefficient, that's what you can expect in the ends. In this is in your book on page 204, I believe was the page that I noticed. They have like little dotted in there. Depending on what the degree is, you could have more character in the middle, but an odd with a positive leading coefficient will definitely end this way. An odd with a negative leading coefficient, an even lead degree, positive leading coefficient, even with a negative leading coefficient is that. Okay? All right. So we all see my issues that I cannot zoom in. I'm not going to try again. That's a sign of a lack of intelligence. Doing something over and over again and expecting a different result. I'm not going to do that. Not going to emulate that. So here's the kind of questions you would had without a calculator. Sorry, I can't zoom in. You're going to have to squint if it looks small. Just can't do it. I'll try it one more time. I just can't help myself. A little bit. Woo-hoo-hoo. I feel so good about myself. Okay. Hey, hold up with your fingers. For letter A, what is the degree of it? What does this degree end up becoming? Hold up with your fingers. Letter A, what does the degree come? Nobody? Can anyone hear me? Anyone there? Nice. Maisar. Good, Antonio. I see you. What is the degree? Good, Aaron. That's it. No one else knows. Okay. Again, I'm fearful of zooming in. If I multiply x times x and then I get x squared, then I multiply that x squared by this other x, I end up getting 1x to the third plus dot, 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 dot. All the rest is x squared, x constant. X to the third is the lead degree. So what you should know is this is what the graph will look like. You have some sort of character in the middle, but it will end like that. So the limit of f of x as x approaches infinity equals infinity. And then I doubt I'll fit this in here. The limit of f of x as x approaches negative infinity is negative infinity. That little arrow pointing down there. Letter B, X to the fourth cube. Be careful. Okay, yeah. Top dog. Hey, with your hands. Your hands are the ends of the graph. Show me. How does both ends of the graph end? Come on, let's do it. Nice. Lindsay. Cool. Can't believe the lack of participation in 7th hour. Just leave me alone, Mr. Samuelus. Aaron, that's a scary skeleton in the background. Thank you, Julia. I was waiting for one more person. She did it reluctantly. I could see her eyes. Oh, fine. I'll do it. Limit of f of x as x approaches infinity. The two students that actually did squat did this. Okay, they pointed up and up. X to the fourth, one like that. All the other stuff will give those little loops in the middle. So that is both infinity for these two limit questions. All right. Oh, I'm fearful of moving. Be careful. Hey, letter C. Fingers. Joe, where are you going? You're making me dizzy. What would your hands do on this one for letter C? Oh, good. I'm getting some different answers. You got tricked. Those that answered fast. Good, Julia. Holding them up. Emily, you haven't done anything yet. Brr. Aiden, I can't even see you. I see the ceiling light. Goodness gracious. Okay, it's negative x to the fourth. So pat yourself on the back if you did this. Fingers down. Okay, it's not a positive x to the third as the leading coefficient. I saw some people have opposite hands, And I know I'm looking at a mirror image, so so the limits for both of these would be negative infinity. So pat yourself on the back if you located that. That's where that is located. Negative infinity and the limit of f of x as x approaches negative infinity is negative infinity. Then I'm just going to verbalize this last one for time. Holy crap, we really only have 1 minute? Oh my gosh. I don't know what happened. I think I over-explained, and that happened again. I think I over-explained because of our internet problems yesterday. This is negative 2x to the third when you multiply this out. So it's going to end like this. You'll be able to do those things. Okay, so without a calculator, that's what we have to do. I'll have to skip this one, this little matching. I think you get the idea. The last thing I'll look at is, yes, this is different or a bridge to what we're going to do on Friday. So I do have to cover it. Finding zeros of a function algebraically. So we're going to think about how the end behavior should be, and then think about the zeros. So to do this, we actually have to factor. Factoring is coming back. It's coming back today. It's coming back Friday, and we're going to do it all next week until the quiz, and you're going to have to factor on the quiz again. So remember what we did here on factoring like this. We probably had that long. I don't know why that turned into a plus. I apologize. That's a Mr. Samuelus computer malfunction. M equals negative 12 and A equals 4. Yeah, you got to get to your methods of factoring right away. Don't go anywhere. Half of you came late anyway. Actually, a majority of you came late. So just let me finish this. Negative 12 and 4. Okay, so what multiplies a negative 12 and 4? Negative 2 and positive 6. You bust this up to equal that middle term, those magic numbers. And you factor by grouping here. S is 0 equals, take out an x. Take out a 2. Finish off the factoring. Pull out that GCF 3x minus 2. You factored as a freshman. You factored as a sophomore. You factored as a junior. You factored in chapter PR. So we must know how to factor. Add 2, divide by 3. Then you'll find out that, no, you already know this. Zeros are actually x-intercepts for the graph. So on Friday, we're going to put zeros together with expected end behavior and have what the graph is supposed to look like. You can go ahead. Aiden already left. See ya, Aiden. Boy, he was fast. It's like in school, Elizabeth left. It's like the bell rang and I was standing in front of the door and they ran me right over to get out of the school. All right. And I'm laying on the ground all beaten up. And anyway, 0 equals, you can go. I'm done joking. If you really care, you should stay though. Ooh, there's a trick. Should I show Mr. Samuels that I care? Am I staying? Who knows? I do have a good point to make on this one though. You pull out a GCF. Be interesting to see if anyone's left when I look up. Then I could do a simple MA. What multiplies -2 adds to -1, -2, +1. And then the point I have to make on this, when you do the zero product property, students often lose this one. This is x equals 0. They just lose it. They don't put that one in there. Okay, all kidding aside, it is tough in this e-learning internet, YouTube, trying to get students to interact and stick around with you. But we're done. That's a little bye-bye. Hopefully my computer at some point works the right way. Alrighty. See you later. If you have any questions, go for it.